Hi, this is Randy Rice. I'm just going to go through a brief demonstration of the ACTS tool from NIST. And ACTS is a tool that can be used for combinatorial testing, such as pairwise testing. So the best way to find the tool is just to do a Google search or something on it. ACTS tool NIST typically finds it. And there it is. You can, well, both of these links should work. Let's try the first one here. And just go to downloads. Here's the link, the Advanced Combinatorial Testing System. You'll also notice, though, that there's some guides and some things here. Now, actually, to get this is not just a download link. You have to send an email to Rick Kuhn to get a copy of it. So this is basically where you find it. Once you install it, just click on the file for ACTS GUI. It's a jar file, and it will open up. So this is the main window that you'll be dealing with, and so we're going to add a new system. And we'll call this platforms. And so the first parameter name here is we'll make it OS. And you can either have Boolean or enumerated values or a number or a range. So we're going to do enumerated values. And so we're going to say iOS, let's just say 6, iOS 6.1, iOS 7. I'm just putting a few of them out here. iOS 8, iOS 9. Now I don't really like that 6.1 in there, so we'll just remove that and just do basic iOS, those values, and let's just for good measure put 9.1. That'll be fine. Now I did just make a mistake there, but this gives you a chance to show how you can modify it. So we want to add iOS 9.1. There we go. Now it's the way that I wanted it. Another parameter that we might want to put in here is phone, and this will also be enumerated, and we'll put iPhone 5, iPhone 6, iPhone 6S, and once I think about it, let's go back and make also 5S, put that in there too. We'll add those to the table, and then we're going to put browser, and then we'll put Safari, Chrome, and Firefox. So the main thing I'm just trying to show here is kind of how the tool works, and that this will give us all we need to know. So with that we'll add the system, and you'll see here on the left we see kind of a tree structure, and then what we can do here is click on this icon to do the build of it, and it's using the algorithm shown up here. So if we want to look at the build options, here, we can see that there's several different algorithms, and you can actually do this at pairwise strength or triple wise, 4-wise, even mixed strengths in doing this. But so those combinations here, we have 5 times 4 is 20 times 3 would be 60 possible combinations. What we've done with pairwise is reduce this now to 20 combinations, just testing the pairs of things. Now, yes, there's 40 that we're not testing because we're just testing the pairings of these. So that's the whole concept behind pairwise, is you're just testing the pairs of all the unique pairs of the various conditions that you're testing. Now, of course, you could put other things in here too, like, let's say, for example, we do some testing on this for a while, and we realize, okay, we want to add memory. Okay, that would be something that we have talked about. And this will be also enumerated, and so we'll do 8 gig, 16, and 32. Oh, and one more, 64. The reason that I'm using all iPhone in here and no Android is because you start seeing a lot of conflicts when you start in a pairwise method, if you start mixing across the lines like that. So even though, yeah, you could probably put iPhones and Android phones and all in one big table or one big system here, you would still have to account for a lot of the inconsistencies. Now, it's kind of interesting, I added memory and I didn't add any new test cases, and that's because that typically the size of your table, or the size of the array here, whatever you want to call this, is driven by the 2 highest numbers of conditions that are held. So in that case, it would be 5 times 4 is 20. Now, once again, now that we've added 4, you can take that 60. We have 240 possible combinations that you could see here, and we've covered 20 of those. Now, there is a statistics tab here that shows how many tests, how many covered or number of covered combinations, and so forth. And in fact, you can even put this in a graphical mode, and it will show you kind of the coverage ratio, how many tests, and kind of what that's doing for you in that. But anyway, that's basically the way the tool works. Now, a couple of things real quickly here before I close out. One thing that you can do on this is you can export it into a CV or a CSV format or Excel format. So we'll export it in Excel format. Let's just put it under My Document so that it'll be easier to find here. Now, one of the things, by the way, about pairwise testing is that it gives you the conditions and how to combine those conditions, but it doesn't tell you what the expected results are going to be. That's one of the downsides to the approach, is that you have to specify that. So here we see the cases that we've created. It shows the parameters up there and everything. What I normally do here, if expected results are something that need to be defined, I'll put them down here. Now, of course, it'd be kind of hard to describe it in a way that, you know, we're talking about consistency. So if you're looking for a specific outcome, then you would just put it in that column. Dealing with configurations, you really don't have very much in terms of outcome. All of your comparisons will be images and things like that. But it could be that, you know, it might be that combination is permitted or not allowed, something like that. I think all of these that we're showing here would be allowed. One situation that might pop up, let's look at iPhone 6 with a 8 gig memory. Maybe that might be one that's not available. something like that. Anyway, now you could use this spreadsheet then to power the input to other test tools that you may have. So that's the whole thing with the AXE tool. It's free. It's very secure because NIST is all about security, and so it's a great little tool to get started in doing pairwise testing, especially with a good graphical user interface like we see here.